Welcome to PRISCI-ANTO Educational Academy. In this session, I am going to explain the part B problem in one-dimensional wave equation problem. Let us see the problem. A string is stretched and fastened to 2 points x is equal to 0 and x is equal to L apart. Motion is started by displacing the string into the form y is equal to k into Lx minus x square, from which it is released at a time t is equal to 0. Find the displacement of any point on the string at a distance of x from one end at a time t. Answer is, this is the given one is wave equation, one-dimensional wave equation. The one-dimensional wave equation is dou square y by dou t square is equal to alpha square dou square y by dou x square. So next you have to find the boundary and initial conditions. Here velocity is not given. If velocity is not given, the boundary and initial conditions are y of 0 comma t which is equal to 0 for all t is greater than 0. Second condition number 2 is y of L comma t which is equal to 0 for all t is greater than 0. These two are called boundary conditions. Condition number 3 is dou y by dou t. This is velocity. Dou y by dou t is velocity x comma 0 which is equal to 0. Fourth condition is y of x comma 0 which is equal to, in the problem it is given y is equal to k into Lx minus x square. So k into Lx minus x square. The limit is also given 0 less than x less than L. So 4 boundary and initial conditions needed to solve one-dimensional wave equation. So next, the suitable solution is y of x comma t which is equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Take this equation number 1. This is the suitable solutions. So now apply condition number 1 in equation number 1. So what is condition number 1? Y of 0 comma t. For x you have to apply 0. So where is x? You have to apply 0 in equation number 1. c1 cos px x equal to 0 cos 0 plus c2 sin 0 into c3 cos pat plus c4 sin pat which is equal to 0, because condition number 1 is y of 0 comma t which is equal to 0. Cos 0 the value is 1. Sin 0 the value is 0. Here the value is 0. Cos 0 value is 1. So c2 sin 0 cancel. So in the next step you can write as c1 cos 0 1 into c3 cos pat plus c4 sin pat which is equal to 0. So here you can write as c1 is equal to 0. You can take c1 is equal to 0. c3 cos pat plus c4 sin pat which is not is equal to 0. So use C1 is equal to 0 in condition number or equation number 1. Right? Substitute C1 is equal to 0. Substitute C1 is equal to 0 in equation number 1. So therefore y of x comma t, which is equal to C1 is 0. So 0 into cos px is 0. So therefore C1 will vanish. So C2 sin px. In equation number 1 you got to substitute C2 sin px into C3 cos pat plus C4 sin pat. Take this equation number 2. Now you got to apply condition number 1, now condition number 2 in equation number 2. So apply condition number 2 in equation number 2. So condition number 2 in equation number 2 will become x is L. So y of L comma t, which is equal to C2 sin PL into C3 cos PAT plus C4 sin PAT, which is equal to 0. So here you can write as C2 is equal to, right, C2 is not is equal to 0, because see, if you are taking C2 is equal to 0 and substitute C2 is equal to 0 in equation number 2, the total term will vanish. So that's why we are taking C2 is not is equal to 0. Sin PL, that is also not equal to 0. No, PL is equal to, sin PL is equal to 0 you have to take. Cos C3 cos PAT plus C4 sin PAT, which is not is equal to 0. So what is sin n pi? That is 0. So instead of sin PL is equal to 0, you can write as sin PL, which is equal to 0. You can use sin n pi. Sin cancel. So PL, which is equal to n pi. So P is equal to n pi divided by L. So P is equal to n pi divided by L. Substitute P is equal to n pi divided by L in equation number 2. So y of x comma t, which is equal to C2 sin P is equal to n pi divided by L. So C2 sin n pi x divided by L into C3 cos n pi at by L plus C4 sin n pi at divided by L. Okay, so take this equation number R I am taking. Now before applying the third condition, what is third condition? Dou y by dou t. Third condition is dou y by dou t. So you cannot apply directly. So equation number R you have to differentiate, right? Equation number R partially with respect to t. So we get dou y by dou t of x comma t, which is equal to C2 sin n pi x by L into C3 cos n pi at by L. If you are differentiating, you will get minus. So minus C3 cos, if you are differentiating, minus sin. So minus C3 n pi a by L into sin n pi at by L plus C4 n pi a by L cos sin, if you are differentiating, you will get cos n pi at divided by L. Right? So now apply condition number 3 in this equation. So condition number 3 in this equation. So condition number 3, apply condition number 3 in dou y by dou t of x comma t, which is equal to C2 sin n by x by L into C3 minus C3 n by a by L cos, not cos, sin n by a divided by L n by at plus C4 n by a by L cos n by at divided by L. So substitute here. What is the dou y by dou t of x comma 0? For t you have to apply 0. So C2 sin n pi x divided by L minus C3 n pi a divided by L sin 0 plus C4 n pi a by L cos 0, because the t is equal to 0, which is equal to 0. So here sin 0, that is 0, cos 0, 1. So therefore C2 C4, right? C2 C4. So therefore dou y by dou t of x comma 0, which is equal to C2 C4 n pi a by L sin n pi x divided by L, which is equal to 0. So C2 we cannot take equal to 0 because C2 is not is equal to 0. Already I explained why we cannot take C2 is equal to 0. But we can take C4 is equal to 0. So C4 is equal to 0. Substitute C4 is equal to 0 in equation R. In equation C4 is equal to 0 in equation number. So what we have taken? R. So here y of x comma t, which is equal to C2 sin n pi x divided by L into C3 cos n pi at by L plus C4, that is 0, 0 sin n by at by L. So 0, so we can cancel. Remaining is, right, remaining is y of x comma t, which is equal to C2 C3 sin n by x by L cos n by at by L. Okay, so take this, right, one of the equation you can take, or else C2 C3 you can write as y of x comma t, which is equal to, in general you can write Cn for C2 C3 sin n by x by L cos n by at divided by L. So the most general solution, Cn you can write as Bn. Cn you can write as Bn. Cn is equal to Bn I am going to take. So the most general solution is, the most general solution is y of x comma t, which is equal to summation n equal to 1 to infinity. For Cn I have taken Bn sin n pi x by L cos n by at by L. So take this equation number 4. So substitute, apply condition number 4 in equation number 4. What is condition number 4? Y of x comma 0, t is equal to 0. So summation n equal to 1 to infinity bn sin n pi x by L cos 0, which is equal to k into Lx minus x square, that is given in the problem. So here, which is equal to summation n equal to 1 to infinity bn sin n pi x divided by L, which is equal to k into Lx minus x square. This Lx minus x square called as, you can take as f of x. So therefore this looks like half range Fourier sine series, half range Fourier sine series in L form in the interval 0, L. So therefore you have to find the value of Bn. So Bn value is equal to, that is the formula, 2 divided by L integral over the limit 0 to L f of x sin n pi x divided by L into dx. This is the formula. What is f of x? K into Lx minus x square. So substitute in this formula, you can easily get the answer. So therefore Bn value is equal to 2 divided by L integral 0 to L f of x is k into Lx minus x square sin n pi x divided by L into dx. So this can be written 2k divided by L integral over the limit 0 to L Lx minus x square sin n pi x divided by L into dx. So you can solve this using the Bernoulli's formula. Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. So u is equal to Lx minus x square, v is equal to sin n pi x divided by L, u dash L minus 2x, u double dash minus 2, u triple dash, which is equal to 0. So v1 is equal to, sin if you are integrating, minus cos n by x by L divided by n pi by L, that can be written as minus L divided by n pi cos n pi x divided by L. v2 is equal to minus L square divided by n square pi square sin n pi x by L. v3 is equal to, sin if you are integrating again you will get minus sign, so that's why L cube divided by n cube pi cube cos n by x divided by L. So u v1 formula minus u dash v2 plus u double dash v3. So substitute in the formula. So therefore which is equal to u v1. So which is equal to, Bn is equal to 2k divided by L u v1 minus Lx minus x square, u v1 L divided by n pi cos n pi x divided by L plus L minus 2x L divided by n pi L square n square pi square sin n by x by L minus 2 into L cube divided by n cube pi cube cos n pi x divided by L. The limit is 0 to L. So when you apply the upper limit, first term will become as 2k divided by L. First term Lx L square minus for x L square. So first term will become vanish. Second term will be sin n pi L divided by L. So L cancel, you will get sin n pi. So second term is also 0 because sin n pi is 0. Third term will be cos n pi. So therefore minus 2L cube divided by n cube pi cube cos n pi L divided by L. L cancel. Next, when you apply the lower limit is 0, first term will become 0, second term will become 0, third term will become 2L cube divided by n cube pi cube cos 0. So answer is 2k, Bn is equal to 2k divided by L 2L cube divided by n cube pi cube is common. So 1 minus cos n pi. So L cube cancel. So 4k L square. 4k L square divided by n cube pi cube. 1 minus cos n pi. 1 minus 1 power n. 1 minus of minus 1 power n. 1 minus of minus 1 power n, which is equal to 2 if n is odd, which is equal to 0 if n is even. If n is even. So here, if n is odd, you will get 4k L square divided by n cube pi cube into 2. If n is odd, which is equal to 0. Which is equal to 0 if n is even. So therefore, Bn value is equal to 8k L square divided by n cube pi cube. This is Bn value. So substitute Bn value, right, in equation number 4. So what is the equation number 4? Equation number 4 is y of x comma t is equal to, so y of x comma t, which is equal to summation n equal to odd to infinity. Bn value 8k L square divided by n cube pi cube sin n by x by L cos n pi at divided by L. Now here you have to write y of x comma t, which is equal to summation n equal to 1 to infinity, not odd to infinity. 1 to infinity means 8k L square divided by 2n minus 1, because odd number 2n minus 1 whole cube pi cube sin 2n minus 1 pi x divided by L cos 2n minus 1 pi at divided by L. So this is the final answer.